Hello everyone, we are Group 2. Today we will discuss the Furniture Fire Case. These are our content. Then I will briefly explain what happened. A fire destroyed a Tampa, Florida warehouse and its inventory. The retailer filed an insurance claim estimating the lost profit using the gross profit factor. To estimate the lost profit, the store calculated its gross profit factor using last year's sales data. The retailer sold 3,005 furniture pieces last year, claiming that they found a sample mean GPF of 50.8% with a sample size n equals 253. Based on two independent random samples, the first of those is 50.6% from 134 invoices, and the other one is 51% from 119 invoices. However, the insurance company argued that most of the items lost in the fire had a GPF below 48% and that the retailer selectively chose high-margin products to inflate the GPF.
By using the data provided in the fire file, we can use these two formulas to count population mean and standard deviation that run to the four decimal place. We can get the population mean, mu, equal to 48.901%, and the population standard deviation, sigma, equal to 13.8286%. To check whether the data was collected randomly and independently, we use significant test. If the store was honest, a sample mean should be a valid estimate. We then make the assumption null hypothesis mu less or equal to 48.901%. We want to prove the high margin product liberty selected and the mean was overestimated. We make the assumption of alternative hypothesis mu bigger than 48.901%. We set significance level alpha equal to 0.05, which means the probability of observing this formula p-value below 0.05, and we can conclude there may be a fraud. Starting with sample 1, the store claims a random sample with a sample size of n equal to 134, and the average GPF equal to 50.6%. We use 4 steps to analyze this case. Firstly, it states, we use information from previous page and let X bar be the mean of GPF of sample 1. Then we can find what we want. Probability of X bar more than or equal to 50.6%. Step 2, plan. We check about 3 characteristics to help us analyze. Assume take the sample randomly. Then we can get the expected value equals sample mean mu of X bar equals population mean mu equals 48.901%. For n equals 134 smaller than 0.1 times of population parameter, the 10% condition is met, and we can get sample standard deviation is 1.1945%. And by the center limit theory, the sample size is bigger than 30, which means the sampling distribution will approximate normal. Step 3, do. After we check the characteristic in step 2, we know this sampling distribution is a distribution approximately normal with mean equal to 48.901% and the standard deviation equal to 1.1945%. Then we can count the P of X bar more than or equal to 50.6%, and we can get the p-value of sample 1 approximately equal to 0.0775. In the picture, the yellow part is the significance level, and the black line is the z-score of X bar. And finally, we have the conclusion. Because the p-value is bigger than the significance level, we fail to reject H none, and we don't have convincing evidence that the store was fraud.
For sample 2 with the sample size of n equals to 119 and sample mean GPF equals to 51%, we state the population mean, population standard deviation, the null hypothesis, and an alternative hypothesis. What we have to find is the probability of the mean GPF of sample 2 greater than or equals to 51%. Assume that the retailer's sample was taken randomly. The mean GPF of sample 2 equals to population mean 48.901. For independence, since 119 less than or equals to 0.1 times of n, the 10% condition is met. So the sample deviation is about 1.2675. For normality, with n equals to 119 greater than or equals to 30, the central limit theorem says that the sampling distribution of the sample mean is approximately normal. We get the probability of the mean GPF of sample 2 greater than or equals to 51% is about 0.048858, which is the p-value of sample 2. The p-value of sample 2 is less than 0.05, so we reject the null hypothesis and accept the alternative hypothesis. Given that the retailer claims a sample mean GPF of 51%, the probability of obtaining such a result under the assumption of SR is extremely low. It means this sample mean is significantly different from the population mean GPF, strongly suggesting the sampling process may not have been truly random, and there may be fraud.
According to our test, sample 2 is not taken by SRS, while sample 1 is randomly selected. The approach of directly averaging the two samples to obtain a sample mean GPF equals to 50.8% with the sample size n equals to 253 is invalid, so the retailer's claim is not honest.
Finally, let's talk about limitations. We divide it into two parts to explain. First, is a limitation that we will encounter in this Furniture Fire case. We will use sterified sampling to increase the likelihood of obtaining reasonable results. For example, group furniture by their types, and then take a certain numbers of them from each group as samples. And the store may have drastically changed its sales strategy this year, which could make this year's true GDF cannot be accurately estimated using the GDF mean from last year's invoices. Also unable to do subsequent hypothesis tests. For example, if there are a lot of high-profit products sold this year, it will cause the actual data to divide by the estimated data. Second, let's talk about a limitation of the method. We will need a population parameter for statistics, and there's a possibility that the population parameter is not accurate, and the calculation result shows that p is smaller than 0.05, means that the result is significant. So, is there fraud? Not actually. A very small p-value means the result is significant. It cannot directly tell us hypothesis is incorrect. P-value can only tell us how consistent the data is with the null hypothesis, not directly determine the correctness of the hypothesis. Statistical significance does not imply causation, nor does it mean that the results are necessarily reliable or meaningful. Extreme p-values need to be interpreted with caution, especially considering factors such as study design, sample size, and multiple testing. And the next is selection of p-value. It can be set lower or higher to make the result more reasonable. And there might be some problem with p-test. The set benchmark HO might be wrong, which could lead to a wrong p-value, which accept it or not. And last, the p-value can only tell us whether the mean GDF of the sample is significantly different from that of the population, but it cannot explain the reason for this difference. Thank you for listening.